So in this lesson, we're going to be talking about decomposing unit fractions using area model to show equivalence. Equivalence means that you have two fractions that the parts are different, but then when you either decompose or you compose, they end up becoming the same or equivalent fractions. Here we go. So the first fraction we're going to be working with and we're going to be using models would be 1/5. We're going to be trying to find an equivalent fraction to 1/5. And here's a model. This model represents 5 parts, 1, 2, 3, 4, 5, and the change of the different color represents the part that's shaded. So thus this model represents 1/5. Now if I wanted to find an equivalent fraction to 1/5, I may be able to put these in rows, which means I'm going to duplicate or make another model just similar to this to find an equivalent fraction. Now these are the same exact fractions, but by naming this, I'm going to count the number of pieces I have at this time, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 parts. And how many seems to have been shaded would be the other colors, which would be 2. So an equivalent fraction of 1/5 would end up being 2/10 by just getting 2 rows. Now we can also find another equivalent fraction by making another row of the same model. By that, we would have another part shaded, and then we'd have an additional piece. Here we would be able to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that would be a denominator of 15, and how many looks as if it's shaded would be 3. So by creating the same model over and over again, we can see that we can create equivalent fractions. So an equivalent fraction to 1/5 is 2/10. Another equivalent fraction to 1/5 would be 3/15. Now what if you do not have a model? If you do not have actual manipulatives, you can go ahead and create your model just the same. Here, we're going to make a model of 5 parts. And we will be shading 1. So this represents a model of 1/5. Now, in order for me to get another equivalent fraction, remember what we did here? We ended up having 2 rows. Now, if I wanted to get 2 rows with this model, what I'd have to do is I'd have to cut this model in half, so I'd have 2 parts. Now, if I cut it to get 2 rows, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which matches up to that denominator. And how many parts seem to now be shaded? That would be 2 parts. If I wanted to do the same thing for that 1/5 to get to that 3/15, I would draw my model again. I would decompose it into 5 parts. I would shade 1, and I would have my 1/5. Now, if I wanted to get in rows of 3, similar to what we had done before, instead of cutting this row 1 time to get 2 parts, I'm going to cut it 3 times, which is decomposing that same model. If we count all the parts, we're going to end up getting 15 parts. And it seems as if we have 3 shaded. Now notice at no point in time did I shade any extras. All we did was to decompose one fraction so we can get the equivalent fractions here.